Welcome back. In the last session, we started clippers and I explained the procedure to solve the problems. Right? If I just repeat once again, the procedure is don't respond to actual input. Right? That instead of responding to actual input, we need to find the transfer curve. Transfer curve is nothing but when VI is changing from minus infinity to plus infinity, what is your V naught? For what? For all values of every input, we should know what is V naught. Steady state V naught. And third one, once you know the transfer curve, respond to input, actual input, and find V naught. It will give you exactly correct answer without any error. And it is a blind procedure. And how to find the transfer curve? Again, I told 2 points. Number one, once you know the diode status, whether it is on or off for some values of input or for some values of input, then how to find the status of diode? Open the diode, find voltage across open terminals, then with respect to your input, for what input your diode is on, for what input your diode is off, that we will come to know. Therefore, decide the diode status with respect to your input. Once you know the diode status, whether it is on or off for different values of your input, then it is simply network analysis. Then try to get the relation between V0 and Vi. Therefore, you will get transfer curve. Once you get transfer curve, then respond to your input, you will get the answer. Okay, this is very easy. Even though you have a trapezoidal, don't confuse with respect to the type of input. Try to get the transfer curve, you will get the answer. Okay, let us apply. The first one, don't respond to actual input. Okay, fine. We need to find the transfer curve like V0 and then Vi. Therefore, for that, what is the step? Therefore, to find the status of diode, what is the first step? Open the diode. Okay, open the diode. Therefore, first step is open the diode. What? For what? To find diode status. Status with respect to input, with respect to Vi. Okay. Therefore, now tell me, if you open the diode, then this is what your V0. Okay. Don't bother about it. Okay. This is what your Vi. Now we are not finding V0. We are finding the status of diode. This is R. Therefore, now tell me, right? Now you just don't connect, but your diode is there here, right? Your diode is there. We are not connecting, but diode is there. Therefore, now tell me, if you open your diode, is there any current path? There is no current path. Resistance and floating, everything is floating, right? And this is what is nothing but your voltage across the diode. This is what is your voltage across the diode. I am just representing forward bias voltage Vd, okay? Which is nothing but your V0, but don't bother about it because it's not to find V0. It is to find status of diode. Then, for what input your diode will be on? For what input your diode will be on? Therefore, I know that when Vi is greater than 0, this is what is, you can say, I told, okay, A and B. Okay, now, the first one, when Vi is positive, when Vi is greater than 0 volt, when Vi is greater than 0 volt, the same voltage is coming here. Let me take ideal diode, okay, approximation 1. Then what is your diode? Because the same plus minus is coming. Therefore, your diode will be on. Therefore, when it is seeing plus minus, the moment you see, when you open the diode, it is seeing positive. When Vi is greater than 0, because the same voltage is coming here. Then when Vd is positive, when you connect it, then it is in forward bias. Therefore, it is on. Therefore, your diode is on. Therefore, what does it mean? When I say diode is on, we got to know the status of diode. When Vi is greater than 0, then your diode is on. Then tell me what is your V0. This is your R and this is what is your Vi. Your V0 is independent of Vi. Your V0 is 0. Your V0 is 0 volt. When Vi is greater than 0 volt. Now, case 2. Tell me if Vi is less than 0 volt, which is nothing but negative. VA greater than 0 means 0 to infinity, all are covered. Now, when VA is less than 0 means minus infinity to 0, that those to be covered. When VA is less than 0, remember your original circuit is this. Then from this, if VA is positive, diode is on. Once diode is on, what is the circuit? Now, from this, if VA is negative, when VA is negative, the same voltage is coming. If you have open terminal diode, then if it is negative, then it is minus and this is plus. Or VD is negative. When VD is negative, this is in reverse bias. Once this is in reverse bias, it is open only, right? Your diode is off. When diode is off, then what is your circuit? Your circuit is, you can take it out, then this is what your V0 and this is what your Vi, this is your R, right? There is no diode, it is open. Then what is your V0? Whatever you have, the same thing is coming, it's like open terminal. There is no circuit, there is no closed loop, then there is no current. Whatever Vi you have, the same thing you will get. Therefore, what is your V0? Your V0 is equal to Vi, as it is. Your V0 is tracking your Vi. I think you got, right? You got what is your V0 with respect to Vi after finding the status of diode. That's what case B is nothing but simply network analysis to find V0. Here there is nothing. Network analysis is nothing but V0 is nothing but what? 0. Short circuit. V0 is nothing but Vi, open terminal voltage. Now we got the transfer curve, right? Therefore, what is your transfer curve? Case A is over and then simply network analysis. That is also done. No need to say A and all. Okay. Therefore, now when you have transfer curve, what is that? Your x-axis is your Vi and then y-axis is nothing but your V0. And what is the break point? Break point is nothing but 0. When Vi is positive something, negative something. When Vi is positive, what is your output? When Vi is positive, your output is 0. Your V0 is 0 for all values of your positive values of Vi. When Vi is negative, your V0 is nothing but Vi. Therefore, this is what it is. I think now we got to know the transfer curve, right? Here your V0 is 0. When Vi is greater than 0, here your V0 is equal to Vi. Now once you know for any value, when Vi is completely minus infinity to 0, it is tracking your V0 is tracking your Vi. When Vi is positive, your V0 is 0. Once you know the transfer curve, then respond to your actual input. Therefore, now come back. Now if I respond, what is your input? Your input is sine wave. Your input is a sine wave. When input is a sine wave, continuously the same sine wave is continued. Now we want to find what is your V0. Therefore, now tell me, this is nothing but 0 and this is what is your 2 volt, right? This is 2 volt and this is your minus 2 volt. Now I think you can segregate, right? This is positive value, this is negative value. Tell me when Vi is positive, what is your V0? I'm just using transfer curve. Now transfer curve is given, which is what is describing your circuit. Your transfer curve is describing your circuit. Once you know transfer curve for any input, not only sine wave, for any input we can find output from the transfer curve. Therefore, now tell me, when Vi is greater than 0, what is your output? 0. For positive values of your input, your output is 0. Now, for negative values of your input, your output is nothing but same as your input. Whatever input you have, this is what is your output. Therefore, what is this? It is a positive clipper, means all positive values are clipped, only negative values are passed. Whatever negative values you have at the input, those will be passed. Whatever positive values you have at the input, all will be clipped. That is what is your output. I hope everyone understood the procedure. See, maybe for this directly you can apply. Positive swing diode is on, V0 0, negative swing diode is off, same as input. Done. But if you follow this procedure, you'll get accurate answer, not for simple circuit. If you have a complex like 2-3 diodes and then different arrangement of diode with respect to resistor, all those things, then if you follow this procedure, you'll get correct answer. Okay? Blind procedure. Take it, then we'll solve the problems. Classroom workbook problems. Okay? Done? I'll give you 30 seconds more, then we will see classroom workbook problems. Okay? All these things you should have done in the lab, should observe, okay? Classroom workbook problems. Okay, problem number 1. In the circuit below, the diode is ideal. The voltage V is given by, okay, circuit is option A, minimum of Vi comma 1, option B, maximum of Vi comma 1, option C, minimum of minus Vi comma 1, option D, maximum of minus Vi comma 1. Okay, let's see. Okay, now I think already problem is with you. Now, according to our procedure, don't respond to the type of input. Actually, here indirectly is asking for transfer curve only. If you see the options with respect to Vi only, see what is the meaning of minimum of Vi comma 1? Let us say Vi is 5 volt. Then what is your V? Therefore, what is asking? What is the problem? Problem is what is voltage V with respect to Vi. Indirectly, this is what your output voltage. This is what your input voltage. Whatever you want to find is nothing but your output voltage, and whatever is the variable or control signal, that is what is your input signal. Therefore, you want to know the transfer curve between V and the Vi. Okay, fine. Therefore, now when Vi is equal to 5, let us say 5 comma 1. Out of 5 comma 1, which is minimum 1, right? Then V is 1. That is the meaning of it. Okay, don't be confused. First of all, let's try to get what is the V with respect to VI, then let's see which is what is satisfying, then you will understand. Okay. According to our procedure, the first step is don't respond to actual input, we need to find the transfer curve. To find the transfer curve, we should know the status of diode. See, if diode is not there, let us say, right, open, then it is simply network circuit, right? That's what I told, it is network analysis, related to network analysis. But diode is there, we don't know the status of diode. Therefore, how to find the status of diode? Open the diode, right? Therefore, now the thing is, open the diode. Open the diode. See, it is a blind procedure, you'll get the answer without putting your brain. Just follow the steps, you'll get the answer. Open the diode. For what? To find diode status. To find diode status with respect to VI. With respect to input voltage VI. Okay? Just listen. When you open the diode, see, we are opening the diode to find the status. Okay? Then once you know the status of diode, then simply network analysis, then find your V, because ultimately we want to find V with respect to VI. Then when you open the diode, open the diode means not simply opening the diode, really we are opening it. And this is what is your VI. And this is what is your 1 ohm, 1 ohm and 1 ampere. And bring back, don't connect, but just you see here, you try to put it here. This is what is your diode. Okay, let me call this as diode D, even though it is not there in the problem statement, but I am calling this as diode D instead of saying diode every time. Okay, now let me call the voltage across the diode. When I say this is what is plus minus, it's not VD, let us say this is what is your reverse bias, right? This is what your reverse bias voltage. Therefore, because when I say plus minus it is easy, therefore let me call this as, it's not VD, let me call this as VA, some voltage. Okay. Therefore now tell me, if VA is positive, what do you mean by VA positive? VA is positive means this is plus minus. When I say plus, plus is connected to N, minus is connected to P. Then if VA is positive, remember your diode is off. When VA is negative, then your diode will be on. Actually the plus minus is indicating reverse bias condition, because your diode is in reverse bias way, right? What it may be, you should know. Okay, therefore now open the diode. Then what is the next step? Find voltage across open terminals. Now you need to find what is VA. Now can you find what is VA? Using KVL. Therefore now tell me, if you open the diode, then what about this 1 ampere? In series current is constant. The same current is flowing, right? When the same current is flowing, then what is the voltage across 1 ohm? The voltage across 1 ohm is equal to what? 1 volt, because same 1 ampere is flowing. In series current is dictated by your current source, 1 volt. Then apply KVL. When you apply KVL, minus VI plus 1 volt plus VA is equal to 0. Therefore what is your VA? Your VA will be equal to VI minus 1. You can call this as equation 1. Okay. Now you need to write 2 steps. Still we didn't find the diode status, but we got open terminal voltage. Now case 1. Case 1. When VA is greater than 0, tell me what is the diode status? Your diode is what? If VA is greater than 0, what is the diode status? Your diode will be off, because plus minus, P is connected to negative, therefore it will be off. Your diode is off. But what do you mean by VA greater than 0? You know already what is VA. VA greater than 0 means VA minus 1 greater than 0, means VA is greater than 1. Therefore, what does it mean? Your VI is greater than 1 volt, because ultimately I want with respect to VI. Even I am calling this as open terminal voltage, it is correlated to your VI. That is the procedure. Therefore, when VI is greater than 1, your diode is off. If diode is off, what is your circuit? Now you find your output voltage. When diode is off, then what is your circuit? You take the circuit, this is what is your VI. Okay. then this is your resistor, your diode is off, then don't bother about it, then this is what your circuit. This is what your 1 ampere, 1 ohm, 1 ohm, this is what is your voltage V, and this is what Vi. Therefore tell me, if this is what is the case, now you need to find what is voltage V. Then tell me what is voltage V. In series current is same, right? Then what is V? Your V is equal to, therefore your V is equal to 1 volt. You found your output with respect to your input. Now what is your input? When Vi is greater than 1, because you know the status of diode, then it is simply network analysis. We found what is your output. Because ultimately I want to find V only. Because that is what is the problem. Right? Then case 2. Because you know the status of diode with respect to open terminal voltage. Therefore now Va less than 0. When Va less than 0 means Va negative. Negative means it will be minus, this will be plus. Your P is plus, then diode will be on. Therefore your diode is on. Diode is on. This is with respect to open terminal voltage. But if you correlate to your input, for what input? Ultimately I want with respect to, I want the status of diode with respect to input. Obviously Vi less than 1. When Vi is less than 1, okay, your diode is on. Once you know status of diode, which is nothing but with respect to your input, then simply network analysis. It is a resistor. Now your diode is on. Then it is a short circuit, right? Then it is a current source, which is 1 ampere. This is 1 ohm, 1 ohm. Now this is what your V, and this is what is your what? Vi. So it is a network analysis. Then tell me what is your V? See, when this is shorted, now it is independent loop. This is independent loop because it is short. Then apply KVL. When you apply KVL, minus Vi plus V is equal to 0. Minus Vi plus V is equal to 0. Then what is your V? Your V is equal to Vi. That is what is this. Therefore, now you got to know what is V with respect to Vi. Now if I plot the transfer curve, what is your input? Vi. What is your output? V. Now what is the break point? Now the break point is the status of diode is changing with respect to your Vi, that is nothing but 1 volt. Therefore the break point is 1 volt. Therefore now tell me, when Vi greater than 1, what is your output? When Vi is greater than 1, your output is 1 volt only. This is what is your output. Okay. When Vi less than 1, what is your output? Same as your input. Therefore you will get this. Okay. This is what is your 0. Therefore this is nothing but your V is equal to Vi, but the break point is 1 volt. Therefore if you observe clearly, right, once you know the transfer curve, this is nothing but your transfer curve, right, this is nothing but your 1 volt and then transfer curve, then tell me what is your maximum output voltage? Your maximum output voltage is nothing but 1 only. Your maximum output voltage is nothing but 1. It cannot get, your V cannot get more than 1 because it is saturated to 1. Your minimum output voltage can be anything, that depends on the input voltage. Okay. Now respond to your inputs. Now let us say case A. Okay. Now let us say Vi is equal to 5. Tell me from the transfer curve, when Vi is 5, what is your output voltage? 1 only. Let's see. When Vi is 5, 5 comma 1, out of 5 comma 1, which is minimum 1, that is also saying 1, this is also saying 1. Now let's say other part. When Vi is equal to minus 5, what is your output? Minus 5 only, because V is equal to Vi, right? Therefore, let us say this is what is your, let me say this is minus 2 or something. Okay. Just for your understanding. Okay, let us say this is what is some minus 2 and this is also minus 2 because V is equal to Vi. Therefore now tell me, if this is what is minus 2, out of minus 2 comma 1, which is minimum, minus 2 is minimum. If it is minus 2, it is also minus 2. Therefore I think option A is satisfying. Okay, therefore answer is A only. Maybe if you see other options, it will not satisfy. Let's see. Maximum of Vi comma 1. Let us say Vi is some 2 volt. When Vi is 2 volt, what is your output? 1. When Vi is 2, out of 2 comma 1, which is maximum, 2 is maximum. Therefore output is 2. No, that is not correct. Output is 1. Therefore all other options won't be satisfying the relation or the transfer curve. Only option A is satisfying. Therefore answer is A. Okay, take it. I hope everybody understood the procedure. Okay, it is a blind procedure. If you know the status of diode, right, with respect to your input, then it is simply network analysis. When is diode on with respect to your input? When is diode off with respect to your input? If you know, but the technique is open the diode, find voltage across open terminals. Then that open terminal voltage, if you find with respect to Vi, then we can find the status of diode and we can find the output voltage whatever you want. I'll have some water and come. Done? Okay. Now let's see, maybe here nothing is given, but I'm asking you, instead of Vi, let us see if there is a sine wave. What is your V? Voltage across the resistor. Right? If you ask me, just we can take a sine wave. Let us say this is what is your Vi. This is your Vi, which is a sine wave, let us say. Then we want to find what is V. Okay, now let us say this is what is having 2 volt and minus 2 volt. Now let's see what is your output. First of all, you need to find the break point. The break point is 1 volt. This is not a break point, which is 1 volt. Basically this is what your 1 volt. Then tell me, according to the transfer curve, if Vi is greater than 1, your output is 1. When Vi is greater than 1, your output is 1 only. Therefore it is 1. When Vi is less than 1, your output is nothing but as it is, same as your input. When Vi is less than 1, your output is exactly same as your input. It is tracking your input. It is continuing the same way. Therefore, what does that mean? It is nothing but positive 1 volt clipper. If your input signal is more than 1 volt, it is clipping. If input signal is less than 1 volt, it is passing as it is. Therefore, it is a clipper. This is what is your output. Okay, even though it's not asked, but what it may be. That's what I told. Once you know the transfer curve is describing your circuit. Okay, then we can find what is your output with respect to any type of input, not only sine wave. Okay, fine. Just to give you a clarity, like how to get your V0 with respect to Vi, if Vi is sine wave. Okay, this is the answer. You can take it, then we can solve second problem. Problem number 2. Done? Okay. Now problem number 2. For the circuit with ideal diodes shown in figure, the shape of the output for the given sine wave input will be. Okay, this is problem number 2. Circuit is this is V in and this is V out. Plus minus V out. Okay, this is what is given. And what is V in? V in is nothing but okay, this is what is 0 and this is T by 2, this is T. Okay, this is what is given. Now asking what is V0, what is V out. Okay, fine. Therefore, what is your V out? Actually, option A, option B, option C, option D, all different things. Okay, this is to confuse you, but I'll modify. Now let's see. See, nothing is given. Therefore, let me call this as some resistor R, irrespective of anything, and let me call this as diode D1, and let me call this is diode D2. Right? With respect to the same thing, can I write in this way? Just listen. Okay. Now, actually, can I twist it? Twist in the sense it is confusing you, right? But can you twist it? Twist is nothing but this is what is your plus minus V in. Now this is what is going to minus V out. Therefore, if I write the same thing, it is simply a PN junction diode. Now this is what is your plus. V in is connected to minus V out. Therefore, this is what is your minus. This is what is your diode D1. Similarly, what is your diode D2? It is connected to minus, but it is connected to plus V out. Therefore, this is what is your minus. This is your V in. Minus V in is connected, but it is something like this. Okay, then it is connected to plus V out. It is connected to plus. This is what your V out, and in between minus to plus we have a resistor. It is very simple, right? Now this is simpler, right? Or you can say this is what is plus minus minus V out. Anything is fine. Okay. Therefore now if you see here, tell me it is straightforward. When diode D1 and D2 will be on, this is what your diode D2, right? When will be, now you need to find the status of diode. You need to open and all. I think directly we can find. Don't bother about the type of input. I already told you, don't bother about type of input. Try to get the transfer curve. Okay. Now tell me, we are trying to find the transfer curve, but without writing like open the diode to find the status diode, because it is known to you, we can go it very fast. Now tell me, when we say plus minus, when Vin is positive, then surely diode will be on, plus then this diode also D2 will be on, right? If Vin is negative, then this is minus, right? Then diode D1 will be off, the same minus when it is open, but this is plus. N is connected to plus, this is also off. Therefore now, when Vin is greater than, case 1, if Vin is greater than 0, positive, then tell me, both diode D1 and D2, they are on. If they are on, what is the circuit? You can take ideal, right? Then the circuit will be this is what is your minus plus V out. This is your R and this is what is plus minus V in. Then KVL. Therefore, what is your KVL equation? Minus V in, right? Then minus V out is equal to 0. Minus V in minus V out is equal to 0. Therefore, what is your V out? Your V out is equal to minus V in. You got to know what is V out with respect to V in. Right? Now, case 2. What is case 2? Actually, I skipped one step. Open the diodes. Find voltage across open terminals. Straightforward. That's why I did not write that step. Directly I could write. Because I know the status of diode with respect to input. When V in is less than 0. When V in is less than 0, which is negative, your diode will be off. This is also off. Right? Therefore, D1 and D2 are off. When they are off, what is your circuit? It is open. Then what is your V out? 0. No current flowing, right? Therefore, even though this is what your V in, the representation, your V out is equal to 0. If you plot the transfer curve, what is your transfer curve? This is your V in and this is what your V out. What is the break point? Your break point is 0 only. Break point is 0. When V in is greater than 0, what is your output? Minus V in. Therefore, your output will be negative. Therefore, this is what it is. When V in is greater than 0, your output is negative. It is increasing in negative direction. When V in is less than 0, what is your output? 0. Therefore, this is what your V out, 0. This is what your V out, minus V in. Okay. Now, with respect to that, now if you plot, now respond to actual input. What is your actual input? Your actual input is a sine wave. Right? Therefore, now tell me, what is your output? When V out is less than, when V in less than 0, for the negative value, your output is 0. Your output is 0. For the positive value, when V in is greater than 0, for the positive value, what is your output? Same as input but opposite. Same as your input but opposite. Same as your input but exactly opposite. This is what you get. This is what your output. Right? The same as your input but it is negative direction because V out is equal minus V in. Therefore, what is the answer? Answer is C. This is what is 0, T by 2 and then T. Therefore, answer is C. Take it. Then we will solve problem number 3. I hope everybody understood the same procedure. I'm just carrying it out. Is this over? Okay. Now, problem number 3. If the circuit shown has to function as a clamping circuit, then which one of the following conditions should be satisfied for the sinusoidal signal of period t? I think this is straightforward, which we had seen. Circuit is, it is Vi, okay. Option A, RC should be very much less than T. Option B, RC is equal to 0.35 T. Option C, RC is equal to T. Option D, RC very much greater than T. Now, means a sine wave having a time period T, this is what your Vi. If this is the case, if you want to get clamping action, what is the condition? That is what is the problem. We know that this is what your clamper, right? Wherever diode and capacitor they are present, you can think like clamping action. Then I already told you this we already solved, right? But now we solved for plus 20 minus 20 square wave, but now this is a sine wave, okay? Whatever it may be, if you want to get clamping action without changing the shape of your input signal at the output, right? What is the condition? Your time constant should be very much greater than, your time constant RC should be very much greater than time period what you have. Therefore, answer is D. Then only it is a clamper. Then only it is a clamping action. Clamping action. Without disturbing your shape of the input signal at the output. Okay, done. Now problem number 4. Two silicon diodes with a forward voltage drop of 0.7 are used in the circuit shown in figure. The range of input voltage Vi for which output is equal to input. Okay. Let me erase this. This is straightforward. Actually, the problem is with you. You need to select the option. For a clamping action, RC should be very much greater than T, which I already told before. Now, problem number 4. Until unless I say don't write, you can track me. So for problem number 4, the circuit is resistor, diode D1 and having plus minus 1 volt. This is D1. Now D2, two volt plus minus 2 volt, right? And this is what is your V0 plus minus, and this is your Vi. This is some R. Okay. Now what is asking is what is Vi range to get V0 is equal to Vi. That is the problem. You have all 4 options. I am not drawing, but you can think. Okay. Now this problem is with you. Now I told what are maybe here we have 2 diodes. Okay. Don't bother here. We need to find the transfer curve. Okay. Now open the diodes to find the status. Okay. The technique is open the diodes. Open the diodes. Open. If you find the transfer curve, it will tell the story. Open the diodes to find status. Diodes status. If you want, you can skip this step directly. If you can find, you can find. When you open the diodes, what you will get? This is open, but let me say this is minus 1 volt. Similarly, this is also open. This is plus 2. I'm just modifying it. Okay. Now this is your R, and this is what is your V in or Vi, and this is what is your 1 volt. This is 2 volt. But bring back your diode. Here also this is diode D1. Here also bring back your diode. This is diode D2. Now tell me what is this? This is nothing but minus 1 volt here, and this is nothing but 2 volt here. Now tell me, when you put your Vi, let us say positive, okay, for what input voltage your diodes will be on and off, right? That is what we need to know. For what input voltage your diode D1 D2 on, D1 D2 off are the combinations, cross combinations. Okay. Now can I say for Vi, because this is minus 1, let me see the negative side first or positive side, anything is fine. When this is what is minus 1, both are ideal, right? If this is what is less than minus 1, then only this will be on, right? When I say this is minus 1, this is minus 2. Minus 1 minus of minus 2, the voltage is 1. Therefore, it should be less than, your N should be less than your P. Therefore, it should be less than minus 1. Then only D1 will be conducting, right? Therefore, when Vi, case 1, when Vi less than what? Less than minus 1 volt. Then tell me, what about your diode D1? Your D1 is on. What about diode D2? Because when Vi is less than -1, this is -1, right? See, when I say all are floating, there is no current, then whatever Vi, the same thing will come here. Therefore, that you see here with respect to the ground. Therefore, here this is negative, then D2 will be off. Then you take the circuit, you know the status, right? Now this is what your resistor, your diode D1 is on, this is the battery, that's it, diode D2 is off. Now this is what your V out, V naught, and this is what your Vi, and this is what your R, and this is what your 1 volt. Therefore now tell me what your V naught. Your V naught is nothing but same thing, the same battery. Therefore your V naught is equal to -1 volt. Right? Now case 2, when Vi is what? Therefore Vi less than -1, that is done. Therefore when Vi is greater than -1, D1 is off, greater than -1, and then D2, right? Therefore now if you see here, only when this voltage, therefore -1 to infinity, that is over. Now -1 to, for what voltage? If this voltage is greater than something, then D2 will be on. Only when this voltage is greater than or equal to 2 volt, then only this will be on. Till that point your D2 is off. Okay, then your Vi, let us say -1 volt less than Vi less than 2 volt. Therefore now your Vi is greater than -1, this is off. Your Vi is greater than -1 but less than 2, D2 is off. Therefore both are off. D1 and D2, they are off. When they are off, right, then what is your output? Then it is simply this, both are off. Then this is what your Vi and this is your V naught. Actually this is what is the problem. Therefore what is your V naught? V naught is equal to Vi. It is tracking. Okay. Now case 3, now the other one, other range, when Vi is greater than 2 volt, then your diode D2 will be on. Your diode D2 will be on. D2 is on, but D1 is off only. D1 is off. Then your circuit will be this is 2. Then tell me what is your V naught as it is, right? Your V naught is equal to 2 volt. Time is over for this session. Okay, you try to analyze whatever I solved, case 1, case 2, case 3, assuming diodes are ideal, because when diode is on, short circuit, diode is off, open circuit. Then we will see what we will continue in the next session. You try to analyze. Okay, thank you.